Welcome to Physics in Under 5 Minutes. Today, we're going to be looking at a specific type of pulley problem that involves a person on a dumbwaiter. In this problem, the dumbwaiter is not accelerating. So let's look at the problem that we're given. A 50-kilogram man on a 20-kilogram dumbwaiter is at rest. What is the tension in the rope? So in case you don't know what a dumbwaiter is, it looks like this, basically a person on a platform holding themselves up by holding the opposite end of the rope. Let's go ahead and draw a free body diagram. The first force is obviously mg for gravity. The second is a little bit more complicated, and this is what makes dumbwaiters different from other types of pulley problems. Rather than just having one tension force, the force from the rope connected to the top of the dumbwaiter, we also have a second tension force that's exerted by the dangling rope on the person's hand. That's because the person is exerting a downwards force in order to create the tension, and so the rope exerts an equal and opposite force upwards on the person's hand. Therefore, we have the equivalent of two tension forces acting upwards on our person and dumbwaiter. Now, the equation we're going to start this problem with is just Newton's second law. The sum of the forces equals mass times acceleration. So once we have that, we can sub in the forces from our free body diagram like this. 2 times the force of tension minus mg. We're considering up to be our positive direction. Next, let's go ahead and solve for mass. We're considering the person dumbwaiter system to be one combined mass, so we'll add them together to get 70 kilograms. Now we just need acceleration. This is going to be 0 meters per second squared because the person is at rest and not accelerating. Finally, we can go ahead and sub everything into our equation and solve for the force of tension. We sub in 70 kilograms for mass, 9.8 meters per second squared for g, and 0 for acceleration, ending up with this equation. Now we can simplify, and simplify again, and finally we end up with a force of tension of 343 newtons. Thank you for watching, and I hope that was helpful.